So let's get back to that y equals 4x that we had just started with. So we talked about the fact that if you don't know how to graph something, you can use a table every single time. So let's graph y equals 4 to the x. All right? So let's make our table of values. Now, I'm going to start you right off the bat by saying probably one of the only ways you're going to be able to graph this is by making a table of values, okay? You can get a couple points here and there, but to really make sure you're getting those right points, there's not a quick, easy way to just kind of memorize it like that. So let's do this. And huge hint, the 5 easiest points to use are going to be your domain of -2 to +2 going by ones. So those are the points we're going to use. The other thing that I want to kind of let you know is the easiest place to start is with your 0. All right? So let's kind of ignore these negatives for a minute and let's start with 0. So I literally just make this my x and I put it in here, which means y equals 4 to the 0. This is something that we may or may not have seen before. We are going to see it. Any number, any base, any variable to the 0 power is always 1. A to the 0 power is 1. 5 to the 0 power is 1. 24 to the 0 power is 1. I know it seems strange. We're going to get into that in more detail later in a couple more learning targets. But for right now, I just need you to know that anytime your exponent is 0, the whole thing turns into 1, not just the exponent. So when I made that x 0, y was 1. It had a corresponding value of 1. Now let's make that exponent a 1, meaning y equals 4 to the first power. Well, 4 to the first power means just 1, 4. So that's 4. Now let's make that exponent a 2. That means that y is going to be 16, okay? So I have, and remember, your ultimate goal is to get this onto your graph. So I have 3 really important points, okay? I have this point right here, which we've kind of referred to as the Y-intercept before, all right? So I'm going to have 0, 1, which is this right here, all right? And my next 2 points, I have our 1, 4, which is right here. And then my next point is 2, 16. So we may have seen this one before. 16 is way somewhere up here, right? So right now, I have, except we're going to make sure it goes through it. So right now I have part of my graph, but I'm kind of missing this other part over here. I need to know what my y value is when my x is -1 and when my x is -2. And here's the deal. You know it's going to be a pretty teeny number. In other words, it's going to be less than +1, right? So remember what I was talking about when it's going to be between that 0 and 1? So I need to know exactly what fraction is going to hit at -1 and when my domain is -2. So we have to make a decision. There's 2 ways to do this. You have option number 1. Your option number 1 is to either work with negative exponents, or your option number 2 is to divide fractions. And man, I know what you're thinking. Neither one of those options sounds great. I'm going to show them both to you. Option number 1 is to just work with a negative exponent. Okay, so here is what it is. Because if you understood the review of that negative exponent, it shouldn't be too bad. So let's make x in this right here -1. So when I make x -1, y is really, do you remember what we talked about in that previous video? Y is really going to be 1 over 4 to the positive first power, which is just 1/4. Okay, so that's going to be 1/4. All right, awesome. I just got one of them down. So this is 1/4, which is actually really teeny. It's about, 25% of the way up. Okay, now I'm going to make that exponent a -2 and take 4 to the -2nd power. So let's make that 4 to the -2nd power, which is the same as 1 over 4 to the +2 power, which is the same as 1/16. So let's put that there. And man, that's tiny. That's so tiny you can probably barely even do it justice on this this is half a centimeter here. You just got to get it really, really, really close. And then you're going to do your best to make it look like it doesn't touch this line, but it is going to keep going, so you're going to want to extend that, okay? So we're going to notice a few things in a minute here. But before we do that, I need to show you option 2, because you may have looked at that and said, oh my gosh, negative exponents, I'm so confused. Let's just do option 2. And you know what? That's a beautiful part about it being an option. You get to choose which way. And the way I show you right now, you may like better. Fractions. You're going to either multiply or divide those fractions, okay? So let's talk about that. I'm going to use my green because that's kind of my rate of change. Even though it's not constant, it's still changing by exponentially. So you remember that this pattern here, back on one of those videos that I showed you, that pattern goes by a constant 3. If it's linear, remember it goes +3, +3, +3. But we're not doing linear, we're doing exponential, which means times 3, times 3, times 3. Okay? Well, it looks like 1 times 4 is 4, and 4 times 4 is 16. So once I find this pattern that it's doing here, which means it's being multiplied by 4, I can kind of continue that, except I got to go backwards. So this number times this number, we're going to kind of pretend like those two numbers aren't there right now. So let's say that I didn't just find out that that was 1/16. And I didn't just use negative exponents to find out that that was 1/4. Let's just use some division. Well, if I'm multiplying by 4 going this way to work backwards in my pattern, I'm going to divide by 4. I'm going to take that 1 and divide it by 4. So I'm going to take that 1 and divide it by 4, which basically is 1 divided by 4. Or you could look at it as 1 not times 4, or, multiplied by the reciprocal. Not times 4 or divided by 4 over 1, but times 1 over 4. Well, it's 1/4, right? Which we had. Okay, we just had it the negative exponent way. So now that I know that that's 1/4, and I'm kind of working backwards here, I divided by 4 to get there, I can take 1/4 and divide it by 4 to get what I started with. Because I want to know, what did I multiply by 4 to get 1/4? It sounds crazy, I know, but just kind of think about it. So now that I know that that's 1/4, I want to divide that by 4. And you got to go back to 5th grade here, or 6th grade, multiplying by fractions. Well, first of all, or dividing by fractions, you don't divide, you multiply by the reciprocal. So don't take 1/4 and divide by 4, take 1/4 and multiply by its reciprocal, which gives you 1/16. And we had that. We had 1/16, but we used it, or we found it using the negative exponent way. Okay? So kind of took a little bit longer to explain that, because I want you to know that once you start, I would always start with that 0. Once you start with that 0 and get these numbers, then go ahead and do either negative exponent or fraction. One thing I do want to point out is that you have a third option. But here's the deal with option 3. It doesn't work all the time. Okay? It only works when you just have y equals 4 to the x with no number in front. Because remember how I told you that y equals ab to the x is really the exponential formula? So if that 2 wasn't there, this shortcut is going to work, but with the 2 there, it's not. So let me show it to you, and I'm not sure, you may have already noticed it. Did you notice that if you took this intercept, that 4 and 1/4 are reciprocals of each other? 16 and 1/16 are reciprocals of each other. Okay? So option 3, we're going to say is kind of a shortcut. And option 3 only works when there's no a, meaning you're not multiplying by something. y equals 2 times 3 to the x, the shortcut would not work. Okay? It would not work because of that. All right? But if I had y equals 3 to the x, yes, your shortcut would work. Your shortcut meaning your other 2 points that you're always going to have a hard time finding are going to be the reciprocals of the other one. So it's kind of symmetrical. Yes, shortcut will work. Okay, we'll do a little bit more with that as we go. So, holy cow, that's a lot. But I wanted you to kind of see how to graph y equals 4 to the x. Because now what we're going to do is kind of look and see what putting a number in front will do. So instead of just asking you to graph y equals 4 to the x, I'm going to ask you to graph y equals 2 times 4 to the x. So y equals 2 times 4 to the x. Okay? Again, looking at it, you may have no clue how to start this, and that's totally okay because we're going to make a table of values. And we're always going to use these 5 points. And we're always going to start with this 0 right here. So let's kind of see how this changes things. I'm going to literally just show the substitutions. I want you to take 2 and multiply it by whatever 4 to the, that's x, 0 power is. And 4 to the 0 power, do you remember what I said? Back here, anything to the 0 power is 1. So I want to take that 2 and multiply it by 1. And so that y is 2 when I made x 0. Now let's see what y would work out to be when I make x 1. So let's do y is equal to 2 times 4 to the first power. Well, 4 to the first power is just 4, and 2 times 4 is 8. Let's make that exponent 2. And you don't have to show this work every time. You can totally do this in your head. This is just me kind of showing you how we arrive at it. 2 times 4 to the second power. Well, 4 to the second power is 16, and 2 times 16 is 32. Man, that got big fast, right? Okay? So I kind of might even look at this and say, all right, I have 3 easy numbers. These are my 3 easy points. Your goal is to get 5 points. So I'm going to start at 0, 2. I'm going to put 1, 8. I should have made my graph a little longer. And then, man, not even going to happen on this graph because when x is 2, y is 32 somewhere all the way up here. So maybe we'll even just put a crazy point right there. So it's 2, 32. So you have this. And if you remember in that preview video, you remember the guy saying, you know, the bigger this number is, y equals 2 to the x kind of goes like this. 3 to the x gets a little faster. 4 to the x gets a little steeper even. Okay? So now it's time to kind of fill in these 2. It's always, this is really where your work is going to come in. It's always going to come in with finding those 2 coordinates because these 3 are kind of easy. Remember what I said about the shortcut. To find these 2, you have option 1, which is negative exponents, option 2, or awesome option 3, if it's available. But because I have this kind of number that I need to multiply it by, it's not going to work. Okay? So I can't just make this 1/8 and this 1/32. It's not going to work because of that 2. If that 2 wasn't there, go for it. That's what I would use every time if you can. All right. So now I have to choose. I will use both options one more time just so you kind of have a good feel and an idea how that works. So let's do the negative exponent option. Okay, I'm going to do it again. Option 1. I have to take that negative 1 and put it there, which means, and this is kind of why I had to show you something a little earlier. So your y value will be 2 times whatever 4 to the negative first power is. So do you remember when I showed you on the previous video what to do here. You kind of create a fraction here. The only thing that moves, though, is the negative exponent and its base, not everything, which is going to make this a positive 2 over 4 to the positive first power, which is going to give you 2 to the fourth power, which is 1/2. So I'm going to make that 1/2. And I have my negative 1, comma, 1/2, which is super, super close. Let's do the exact same thing again. Let's take this exponent this time and make it a negative 2. So then let's say y is going to equal 2 times 4 to the negative second power, which I then want to move and make it 2 over 4 to the positive second power, which is 2 over 4 times 4, which is 2/16, which we're going to reduce to 1/8. So I have my points. Negative 1 is 1/2. Negative 2 is 1/8, which is so close. And I have those two. I'm going to connect them, but not let them touch. And there's your graph of that, okay? Let's do option 2, which some of you may say, it's all for me. I don't want to do with those negative exponents, although if you want to make a smart student decision here, you're going to see this again. Why not get the practice for it now? Okay? And some of you don't like fractions anyway. So remember, let's pretend like that 1/8. Well, actually, we'll just leave it there. So let's pretend like I'm looking to get this. What was the rule here? Remember, from 2 to 8, I multiplied by 4. From 8 to 32, I multiplied by 4. All right? So instead of multiplying by 4, if I didn't know what that 1/2 was, I would divide 2 by 4. So you're going to take that 2 and divide it by 4, which is the same thing as 2 divided by 4, which is 1/2. Or you could look at it as don't divide by 4, multiply by 1/4, and that's going to give you 1/2 either way. So when I made that, I just divided that by 4. Then I need to take that 1/2 and divide it by 4 to get that 1/8. Yeah, I know it's already there, but we're pretending it's not. We did it the negative exponent way, and now I'm showing you the fraction way. So I need to take that 1/2 and divide it by 4 to continue the pattern, which means don't divide by 1/4, or don't divide by 4, multiply by 1/4, and there's where your 1/8 comes from. Like it is right there. So the choice is yours. You can choose to do the negative exponent or the fraction way. So this is an example of exponential growth because this number right here is a number greater than 1 because your b is greater than 1. I also want to point out to you that I have this circled in pink, and that here it is right here, and here it is right here. Let's take a look at that for a minute. This number in front, I'm recording notes in my classroom. This number in front is going to be essentially your 0 value, which is going to be your y-intercept, right? Every single time. Let's kind of go back and look at that. What number was really in front? Wasn't that really 1 times 4x? So there's my 1, there's my 1, there's my 1. So make that connection. This is all about making connections. Okay, we're going to move on to exponential decay next.